everyone, and welcome. Today, we're diving into a machine learning algorithm that's, well, it's both incredibly powerful and surprisingly easy to wrap your head around: the random forest. We're going to see how a really simple idea, basically asking a bunch of friends for their opinion, can lead to some of the most accurate predictions in all of technology. I mean, we all have, right? You're stuck, you're weighing all the pros and cons, trying to figure out the best possible path forward. It's just a very human thing to go through. So let's bring this down to earth with a simple example. Say you're trying to figure out if you're going to like a brand new movie. You've got all this info to sift through, right? The genre, the director, the actors, what the early reviews are saying. So how do you actually make the call? Well, you could just ask that one friend of yours who's a total sci-fi geek. Their opinion is great, for sure, but it's still just one point of view. A much, much better way to do it: pull a whole group of your friends. Each one is going to bring their own unique taste to the table and focus on totally different things. And that right there is the secret sauce behind the random forest algorithm. Your one friend's take, that's like a single decision tree. It's a simple little model. But when you combine the votes from all your friends, that's a random forest, a way more robust and, frankly, a much more accurate prediction. This whole concept is what's called an ensemble method, which is really just a fancy way of saying a team of simple models working together to get a better result. So, what is one of these decision trees anyway? Just think of it like a simple flowchart. It basically asks a series of yes or no questions to get to an answer. For our movie, it might ask, hey, is the director someone you usually like? A yes sends you down one path, a no sends you down another, and it keeps going until it spits out a final prediction. You'll like it or you won't. Simple. Okay, but that brings up a really good question. Why isn't it just called a decision forest? That random part, that's the secret ingredient. It's what gives this whole algorithm its superpower, and it actually comes from two very specific types of randomness. This is exactly how the algorithm makes sure all its little decision makers are diverse, just like your group of friends. So first, each individual tree only gets to see a different random chunk of the overall data. There's a technical name for this: bagging, but that's all it is. And second, at every single question it asks, the tree only gets to consider a random handful of factors. So one tree might only get to ask about the director and genre, while another can only look at the main actor and the movie's runtime. This two-part randomness is key. It makes sure our trees don't all have the same biases. All right, enough with the movie analogies. Let's see how this plays out in a much more serious situation: a bank trying to predict whether or not to approve a loan. This is a classic real-world job for the random forest algorithm. So our first decision tree gets its random piece of historical loan data. Out of all the things it could look at, it randomly happens to focus on the applicant's income. And based on that one factor, it figures the risk is pretty low and casts its vote, approve. But hang on, here comes tree number 2. It was trained on a different set of data, and it was randomly told to focus on other things like the applicant's age. Now, maybe in its data, it sees a pattern where younger applicants are a higher risk. So it comes to a totally different conclusion and votes deny. See, now we have some disagreement. And here comes a third tree to maybe break the tie. Its random set of features leads it to zero in on the applicant's credit history, which, let's say, is fantastic. So it also casts a vote to approve. So what's the final verdict? We just tally up the votes. The forest has spoken. With 2 votes for approve and only 1 for deny, the final prediction is to approve the loan. It's that simple. By combining these simple, slightly different decision makers, we get a collective judgment that's way more reliable than any single one of them could be on its own. It's literally majority rule. And this whole example just shows you exactly why random forest is so popular. It gives you incredibly high accuracy. And a big reason for that is because all that randomness helps prevent something called overfitting. That's a super common problem where a model basically memorizes the training data, including all its weird quirks, and then it totally fails when it sees brand new data. Because it's so strong and flexible, you see random forest being used absolutely everywhere, from banking and e-commerce all the way to medical diagnoses. You know, this quote just nails it. Random forest is a perfect example of these ensemble methods. The big idea is that a team of simple models, when you combine them in a smart way, will almost always do a better job than one single, super complicated model. It's teamwork, but for algorithms. So the next time you're up against a really complex problem, just remember the random forest. It's such a powerful reminder that a lot of times the smartest answer doesn't come from a single genius, but from the collective wisdom of a diverse crowd. And it really makes you wonder, What other huge challenges could we solve if we just applied that same amazing idea?